Welcome to our channel. Today, we're diving into the fascinating world of physics to explore Newton's 3 laws of motion. These laws are fundamental to our understanding of how objects move and interact, from the smallest atom to the largest galaxy. Let's get started. You know, it's amazing to think that these laws, formulated centuries ago by Sir Isaac Newton, still hold true today. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. This is also known as the law of inertia. Think about it. Your phone just sits there on the table, lifeless, until you pick it up. Or a ball will keep rolling unless friction or a wall stops it. That's inertia. It's the tendency of an object to resist changes in its motion. This law is why you feel a jolt when a car suddenly accelerates or brakes. Your body at rest wants to stay that way. And when you're cruising in a car at a constant speed, you don't feel like you're moving at all, do you? That's because you and the car are moving together at the same speed, and without any external force, you just keep on cruising. Inertia is also why it's so hard to stop a train or a massive ship. The more massive an object is, the more inertia it has, and the harder it is to change its motion. It's like the universe is saying, nope, I'd rather just keep doing what I'm doing. So the next time you're struggling to get your bicycle moving or watching a rocket launch into space, remember Newton's first law of motion: inertia is at play. Newton's second law of motion explains how the velocity of an object changes when it is subjected to an external force. This is where we get the famous equation F equals sine ma, where F is the force applied, m is the mass of the object, and a is the acceleration. This equation tells us that the force required to move an object is directly proportional to its mass and the acceleration we want to achieve. So, if you want to move a heavier object, you need to apply more force. And if you want to accelerate an object faster, you need to apply even more force. Let's imagine you're playing baseball. You swing the bat and hit the ball. The force you apply with the bat, combined with the mass of the ball, determines how fast the ball accelerates and how far it travels. A harder swing equals more force equals more acceleration. This law is also why it's easier to push a shopping cart when it's empty than when it's full of groceries. The full cart has more mass, so you need to apply more force to make it move. And think about astronauts in space. They can move massive objects with just a gentle push because there's almost no friction or gravity to resist the motion. It's like a cosmic ballet. So whether you're hitting a baseball, pushing a shopping cart, or launching a rocket into space, Newton's second law of motion is always at work, dictating the relationship between force, mass, and acceleration. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. If you push on something, it pushes back on you with the same force. Think about jumping on a trampoline. You push down on the trampoline with a certain force, and the trampoline pushes back on you with an equal and opposite force, propelling you into the air. The harder you jump, the higher you bounce. This law is also why rockets work. The rocket expels hot gas out of its engines, and the gas pushes back on the rocket with an equal and opposite force, propelling it upward. Even something as simple as walking involves Newton's third law. When you walk, you push backward on the ground with your foot, and the ground pushes forward on your foot with an equal and opposite force, propelling you forward. This principle of action and reaction is everywhere. It's the reason birds can fly, fish can swim, and cars can move. It's a constant cosmic dance between forces. So, the next time you're bouncing on a trampoline, watching a rocket launch, or even just taking a walk, remember Newton's third law of motion. For every action, there's an equal and opposite reaction. Thanks for watching. If you enjoyed this video and want to learn more about the wonders of physics, don't forget to like, subscribe, and hit the bell icon for notifications. See you next time. Today, we've only just scratched the surface of Newton's laws of motion. There's so much more to explore and discover about these fundamental principles that govern our universe. So keep asking questions, keep exploring, and keep your sense of wonder alive. The universe is full of incredible things waiting to be understood.